My name is Jill Marshall, and I am a fourth year professor. I'm a geomorphologist and a critical zone scientist. I am looking for both master's and PhD students. And even if you don't have a background in the geosciences, but you're interested in what I talk about, I urge you to reach out to me. Okay, so what do I and my students do? Well, it's pretty broad, so I'm going to give you a snippet here, a constrained snippet. I mainly work on what controls how fast mountains fall apart. So everything from ice, like ice weathering in unglaciated landscapes, to trees, thin soil settings, how trees are a dominant mechanism that for physical weathering that converts rock into mobile sediment. And then that mobile sediment, what controls how fast it goes downhill? What happens when it gets to the river? How does the river respond? And then how do those adjoining hill slopes respond? All of those things control how fast landscapes evolve, and it matters because it controls where we live. It controls the thin skin of the earth, which we depend on for storing carbon, for making soil, for growing food. So, what type of projects do I have? Well, I'm going to give you a really brief overview of a bunch of stuff. But there's a lot more. So if you're interested in any of this, and University of Arkansas, our department's wonderful. If it appeals to you, reach out to me. Okay, this is the Arctic, 68 degrees north, so north of the Arctic Circle. This is me. This is my fabulous PhD student, Emma Menio. This is part of the Richardson Range, and I'm working on a project with Emma is doing a bunch of work there, but I am continuing this work with colleagues at Dartmouth, and what we're interested in across this north-south range is how, as climates change through time, both from in the Holocene, so over a, say, 12,000 year period, but also in the last 40 to 50 years when there's been intense warming in the Arctic. So you've had this major dramatic shift from ice-driven processes, frozen water, to liquid water. And the timing of it, how much you're in any given water regime, is all going to control how fast you can break rock apart, what are the mechanisms that send it downhill, and eventually how is that controlling landscape evolution. So that's one of the big projects I'm working on. There's field work, there's modeling, all sorts of stuff. Oh, so trees, I mentioned trees. I am working on instrumenting trees with force sensors and a whole other suite of instrumental sensors working with a whole bunch of people in observatory settings where we're trying to understand how water transits to the land and wind, when it hits different trees, how those trees respond. It turns out different trees transmit that signal in really different ways below ground. And so the frequency and magnitude of how tree-driven forces, everything from those trees to taking up water at night. And it turns out that essentially the name is tree breathing, right? When a tree takes up water, because that's what it needs to send up to turn into sap, takes up water and it swells and those roots tap on the rock. And they're really small forces, but they happen a lot, like over a lifetime of a tree, like 10,000 times. And so that tapping, we're measuring now the forces that these uptake of water that's happening on the rock, and it matters like whether you're in humid Arkansas or in a Mediterranean climate like California or Colorado. So we're working in a broader way of places to try and understand all these different environmental factors, how they control the frequency, the magnitude of forces that trees exert on rock. Which leads me to physical modeling. So I do a bunch of numerical modeling and physical modeling. This is some fantastic work from former student Jacob Klein. He's now at Ohio State University. But he developed models based on what we measured in the field to try and understand how rock porosity was changing over time. And then finally, the Ozarks. It is so beautiful here. And we have a fantastic cultural diversity. If you like mountain biking, if you like rivers, we've got, I think, 8 wild and scenic rivers. We've got museums that you can't believe. But we've also got these giant blocks that fall down. And there's a whole bunch of questions on these that we're just starting to ask. There's been some people working on it, but in a tectonically quiescent setting, there's some super interesting, dramatic landscape processes going on. So, if you're interested in any of this, please reach out to me. My email is jillm@uark.edu. You can find more information on my website, jillamarshall.com, and everything from rock mechanics and critical zone and modeling. And importantly, I'm building a diverse and inclusive and respectful lab. So if you're interested in any of this, give a shout out. I'm really looking forward to talking to you.